Hey, what's up? It's Mr. G here. We're going to be talking about inverse today, but first let's do the try this. So just evaluate those two functions there and check your answers in a little bit. Alright, so for the first problem, we have f of x equals 2x squared minus 5x plus 4. And we're asking to find f of 3. So f of 3 is our input. So anywhere I see an x, I'm plugging in a 3. So this equals 2 times 3 squared minus 5 times 3 plus 4. And when you plug that into your calculator, you get 7. Alright, if we're looking at number 2, we have g of x equals the square root of x squared plus 9. And we're looking at g of 4, so that's our input again. So anywhere I see an x, I will plug in our input, which is 4. So we have the square root of 4 squared plus 9. You get the square root of 25, which just equals, so g of 4 equals 5. Okay, so let's refresh our memory. What is the inverse? So inverse is the reflection over the line y equals x. So if we had a graph here and we had a point over here, we'll call it -4, 2. We're reflecting over this line, the one that goes through the origin. This is y equals x. So if we're reflecting this, we end up somewhere down here, and it would be 2, -4. So hopefully you can kind of piece together the rule if you forgot it, but just in case, our rule is x, y becomes y, x. So we switch x and y, or swap x and y, and y, and this is what's known as our inverse. And we show our inverse by this little notation. It looks like f to the -1, but it means inverse of f of x. So this is our inverse notation. Okay, how do we find the inverse? Our step 1 is to replace f of x with y equals. So f of x equals with y equals. Our next step is to swap x and y. Our third step is to solve for y. And finally, our fourth step is to replace it back with the inverse notation. So write using our inverse notation, which is f inverse of x. Alright, so let's look at our example. If f of x equals 4x minus 2, what is the inverse of f of x? So we have f of x equals 4x minus 2. Our first step is to replace that with y equals. So y equals 4x minus 2. Our next step is to swap x and y. So x equals 4y minus 2. Now we're solving for y, so we're going to add 2 to both sides, so we get x plus 2 equals 4y. We're going to divide everything by 4, and we're going to bring it up here. So we have x plus 2 over 4 equals y. And now we write using our inverse notation, f inverse of x equals, so we can kind of reduce here, so I'm going to write it like that. So I'm going to write 1/4 x plus 1/2. You can write it as x over 4 plus 1/2, whichever way you're comfortable with, but this is our, this right here is our inverse. It's our inverse function. Alright, flip it over to the back. Alright, so let's look at this example. We have if g of x equals the square root of 5x minus 2, find g inverse of 2. So first we have to find the inverse, because we can't just go plugging in stuff without finding the inverse, because that's what it's asking for. So let's do this real quick. So remember, we replace it. It's y equals the square root 5x minus 2, all under the square root. Switch x and y, so you get x the square root of 5y minus 2. We want to solve for y, so let's square both sides. And you get x squared equals, these cancel each other out, equals 5y minus 2. Let's bring this up here. We add 2 to both sides, so you get x squared plus 2 equals 5y. Divide by 5, and you get x squared plus 2 over 5. And we can replace this with f inverse of x, or g. Oops. Make sure you pay attention to the letters. It's g. G inverse of x. So now if I'm going to find the g inverse of 2, we have our function here. So we have g inverse of x equals x squared plus 2 over 5. So when we want to find the g inverse of 2, so anywhere I see a 2, this is our input, I'm going to plug in a 2, so I have 2 squared plus 2 over 5, and that comes out to be 6 over 5. So that's g inverse of 2. Our answer is 6 over 5. Alright, now let's look at inverse on a graph. So we're going to graph this function, f of x equals negative 4x plus 6. So to find the inverse, let's just graph it in your calculator and find the table of values. So you have xy, go negative 1, 10, 0, 6, 1, 2, 2, negative 2, and 3, negative 6. So I'm going to plot this to the best of my ability. So we have negative 110, 0, 6, 1, 2, 2 to the negative 2, 3 to the negative 6. So what I want you to do is when you plot these, use a ruler or something and make this a nice straight line. Oh, I actually hit all the points. That's pretty awesome. So that's our line f of x, and it equals negative 4x plus 6. So now when we want to find the inverse, all we have to do over here to find the inverse, remember our inverse notation, f to the negative inverse of x. Don't say -1, I almost did. We have our x values and our y values, and all we do is switch them. So we have 10, -1, 6, 0, 2, 1, -2, 2, -6, 3. So if I was to graph those, I have 10, -1, 6, 0, 2, 1, -2, 2, and -6, 3. And again, take a nice ruler. Wow, completely missed that one. And that one. But if you take a ruler, this is our inverse of f of x on a graph, because it reflects over the line y equals x. So this line right here. Through the origin, that's our line y equals x. So if you were to reflect this, that's what it would look like. Alright, let's look at something kind of cool. At least math-wise, it's pretty cool. So we're looking at identity for a composition is I of x equals x. So basically what that's saying is if we have an f of x, we want to verify that f of the inverse of x always equals x. So basically they're asking us to prove that this is true. So let's see if they're right, and we should be right because it's called the identity for a reason. So we have f of x equals 3x minus 5. Our first step is to rewrite this as y equals the square root of 3x minus 5. Now we switch x and y. We have x equals the square root of 3y minus 5. We'll square root both sides. You get x squared equals 3y minus 5. Let's bring this up here. So let's move this over here. So we have add 5 to both sides. So you get x squared plus 5 equals 3y. Divide by 3 on both sides, and we get f inverse of x equals x squared plus 5 over 3. So remember, it asked us to verify that this is true. F of f inverse of x equals x. So remember, in a composition of functions, we have our f inverse of x. We work backwards. So we have f of our f inverse of x, which is x squared plus 5 over 3. Apologies. So now anywhere I see an x in our original f of x function, I'm going to plug that in. So we have the square root of 3 times our input, x squared plus 5 over 3 minus 5. Remember, it's all under the radical. And I get that equals. So you can put this 3 over 1, and when we cross multiply, the 3's canceled. So we get x squared plus 5 minus 5. These cancel. Remember, we're still under the radical, and you get the square root of x squared, which we all know equals x. So congratulations, you did your first proof, and you verified that f inverse of x of f equals x. Alright, see you tomorrow in class.